Hello again, Year 8s. It's forces, waves and generating electricity. We are on lesson 7. We're carrying on with this spring investigation. It's all about something called Hooke's law. Now you can see here that is the original length of the spring with no weight added. That's the length of it, right there, whatever it is in centimeters. If, however, you add 1 Newton of weight to it, that's 100 grams, and you can see that here. So we've got a weight force downwards of 1 Newton. You can see that the spring has got longer. But by how much has it extended? It is this measurement there. So when the weight force was 0, the extension was 0. But as we add more weight, you will see that the extension gets bigger. So here the extension is from this point all the way down to here. The extension is increasing as we increase the weight force. This is the results table that I'd like you to draw. Now our independent variable always goes in this column here. That will be the weight force. Always include units in newtons. The dependent variable, the thing that we measure as a result, always goes in the right hand column. Now we haven't got any repeats today, so what we have is the spring extension, and we measure that in centimeters, cm. Now the reason that we put the units in the heading, and I'm just going to highlight these headings for just a moment. The reason that we put it in here is because what a waste of ink if we were to write down centimeters in here and here and here and here. That's a waste of time. Seriously, you just write it down once. Write it down once only in the heading. So these are the results that I would like you to write down. When the weight force was 0, there was no extension. We're going to go from 0 to 5 weight forces. So if you were to write this down in your method, the range of results for weight force would be from 0 to 5. Whereas the interval would be you are increasing the interval by 1 every time. So the range was 0 to 5 and the interval is 1 Newton. So these are the results. When we added a weight force of 1 Newton, the extension was 4 centimeters. At 2 newtons, it's 8. At 3 newtons, the extension was 12 centimeters. This went on to 16 centimeters, which then went on to 20 centimeters. There's a definite relationship here. As we increase the weight force, the spring extension also increases. So, using our results, I'm going to construct a line graph. I'd like you to have a go at it. I'd like you to pause this now, but I am going to complete the line graph now. So, the independent variable was our weight force in newtons. The dependent variable was the spring extension. Don't forget the units, it's in centimeters. And now I think about my scale. Now, where these two axes cross, that is going to be 0. Now, I've got to get up to 5. I've got to get up to 5 newtons. So I think every big square, remember, it's either 1s or 2s or 5s. I think I'm going to use 1s here. 1, and then 2, and then 3, and then 4, and then 5. And the maximum spring extension was up to 20. I'm not going to use 1s here. I might not even use 2s. Let's have a look. 1, 2, 3, 4, 5, 6, 7. That's no good. Let's try 2s. 2, 4, 6, 8, 10, 12, 14. That's not enough. I think I'm going to have to go up in 5s. Every big square is going to be worth 5 centimeters. So now let's plot these points. Zero newtons, 0 extension. Make sure that you're including crosses, not dots, not blobs, crosses. At 1 newton, it was 4. 3, 4. At 2 newtons, it was 8. 5, 6, 7, 8 is there. At 3 newtons, it was 12. 10, 11, 12. Boom, right there. At 4 newtons, it was 16. 15, 16 is there. Boom. And the last one, at 5 newtons, it was 20 centimeters. Boom, like so. Once again, as we increase the weight force, we are increasing the spring extension. You can clearly see that. Now for the line of best fit. Obviously, you're going to use a ruler. Obviously, you're going to start at the origin. And you can clearly see here a very, very nice relationship. Put your line of best fit in. And there it is. And in actual fact, what you can say is, if you double the weight force, you will, using a ruler and some extraction lines now, I'm going to do this in a different colour, doing green. Let's try this now. When you double, you get to, it's quite tricky. Most tricky. It is not letting me. Put my line in. That's 8. So at 2 newtons, the spring extension was 8. And then at 4 newtons, the spring extension was 16. So at 2 newtons, the extension was 8 centimeters, And then at 4 newtons, the extension was 16 centimetres. So what I'm suggesting to you is, if you double the weight force, you double the spring extension. The two variables, we can call them directly proportional. You double one, you double the other one. If you triple one, you triple the other one. If you halve one, you halve the other one. Really important. That is Key Stage 4. That's GCSE standard to be able to notice this number link. I wonder, in your own words, can you provide a conclusion that is number linked? Obviously, we're going to be looking at the weight force in newtons, and we're also going to be looking at the spring extension in centimetres. That's all, folks, for this lesson. Well done.